Hi everyone, welcome to the guided notes on the Unit 1 test study guide. We're going to start with number 1, and we're going to start inside the parentheses following the order of operations here, parentheses, exponents, multiplication, division, addition, and subtraction. So inside the parentheses I can see that 8 and 12 can be divided by 4, and so I'm going to end up with 2 over 3. Now the rule is when you have a power separated by division that you subtract. That should sound familiar from the rules of exponents. So I'm going to take -5 minus -6, and that becomes a to the 1. That goes up top in the numerator. B minus a -2. That is b, let's see, minus -2 plus b to the 8. 4 minus -2, yeah, b to the 8. Now I'm going to square that whole thing. Sorry, that's not true. I knew that didn't quite sound right. That should be b to the 6. Thank you. Now when I square all of that, I get 4 over 9, a squared, b 12. The next one I'd like to look at is number 7. And you are supposed to factor completely. We're going to factor out a greatest common factor of 2w. And on the inside of parentheses, end up with 6w squared plus 13w minus 5. We factor this. I'm going to factor by grouping. If you have a method that you prefer, do that. I'm looking for the product of two numbers to be -5 times 6, so to be -30. And I'm looking for two numbers that sum to 13. I think those numbers should be, the signs should be different, and they should be 15 and w and 2w. The signs on those should be plus, minus, -5. Bring down the 6w squared, and the 2w also just comes down because that's what I factored out before. Now, a greatest common factor here, the left and the right-hand side. That is 3w, and on the inside I get 2w plus 5, and I factor out a -1 here, and I get 2w plus 5. And so my two factors are what's left on the outside, 3w minus 1, and 2w plus 5 on the inside. That is the complete factorization of question 7. The next one we're doing is question 14. And you've got a fraction multiplied by a fraction. You could do this one of two ways. You could multiply numerator times numerator and denominator times denominator, but the first thing I would suggest is factoring these and trying to cancel any terms that you can. So I'm going to factor out an 8a squared here and get a plus 3. In the denominator, I'm going to factor out 18 and get a plus 3. Well, that's mighty convenient. On the top here, I'm going to have, I'm going to do the work here. I'm going to have a product of two numbers be 5 times 24. That's 120. And the sum of those two numbers be 43. If you're not sure how to factor that, you can type into y1 120 divided by x, and it'll give you a list of, then you go into the table, and in the table it'll give you a list of all of those factors. However, I believe that those numbers are, let's see, 43, 40, and 3, because they have to add to 43. So I'm going to do this as 5a squared plus 40a plus 3a plus 24, and factor that by grouping. I'm going to get a 5a outside, and on the inside a plus 8, and then over here 3, and get an a plus 8. And so what I end up with is parentheses, this will just be over the denominator. I would get 5a plus 8 and plus 3. 5a plus 3 and a plus 8. Then in the denominator, I can factor out a 2a and get 5a plus 3. Well, that's nice. 5a plus 3's cancel here. A plus 3 and a plus 3 cancel here. So it looks like I've got 8a squared over 18 times 2a, and then an a plus 8 left. Simplify that one step further, and it looks like you can divide by, let's see, 36 and 4. So you can divide by 4 and get an a. So you can get a 2 here times a plus 8. And then in the bottom, if you divide by 4, 36 divided by 4 is 9. Okay, the next problem that I would like to focus on is 22. And that involves adding and subtracting radicals with radicals. So we need to break these down. Negative 4 times square root of 9 times square root of 3 plus 6 times square root of, let's go with 5 times square root of 9 minus square root of 25 times square root of 3. So you get negative 4 times 3 square roots of 3 plus 6 times 3 would be 18 square roots of 5 minus 5 square roots of 3. That looks like negative 12 square roots of 3 plus 18 square roots of 5 minus 5 square roots of 3. I'm looking at negative 17 square roots of 3 plus 18 square roots of 5. The next problem is 27. We have to rationalize the denominator by multiplying by the conjugate of that, so that would be 5 minus the square root of 3. This is a FOIL and distribution problem with the idea that if I multiply by the opposite in the denominator, there will be no middle term. So I'm looking at 10, if I distribute, minus 2 square roots of 3 plus 5 square roots of 3 minus the square root of 9, which of course is minus 3. Okay, divide that by 25. Middle terms cancel of plus 5 root 3 minus 5 root 3, and I'm going to be minus the square root of 9. And I end up with, let's see, 10 minus 3, that would be 7. And plus 3 square roots of 3 divided by 25 minus 3 divided by 22. Okay, the next problem is number 32, where we review this eye chart that we talked about earlier in the year, where I to the 0 is 1, remembering that I, of course, is equal to the square root of negative 1. I to the 1 is just itself. I squared is negative 1. That's just the idea of taking I squared as being the square root of negative 1 squared. It just gives you negative 1. And then I cubed is negative I. We go around the circle in this pattern. So if I want I to the 52, well, if I take 52 and I divide it by 4, that's 13. If you remember how I'm trying to get here to I to the, this could be I to the 2 times I to the 2 times, I to the 13. Actually, no, that's not true. Let's just go back and do this a different way. One way is that you could count around 52 times. Another way, which is fine, 1, 2, 3, this would be 4, 5, 6, 7, 8, 9, 10. Just keep counting around the circle until you count to 52. But there's probably an easier way to do this. So if we take I to the 4 13 times, that's what I was trying to get at before, isn't I to the 4 the same thing as I to the 0? So isn't that just 1 raised to the 13? And that answer is just 1. Okay, the next problem I'd like to look at is 37. It's reminiscent of problem 27, except instead of a complex number with a radical sign, we're looking at complex conjugates here with I. So I want to multiply by negative I minus I. That'll cancel the middle terms. And what I do at the bottom, I have to do at the top. So I'm looking at 56 plus 7I minus 32I And I'm just going to stay with plus 4i squared for now. We'll simplify that in the next step. If I do the same thing on the bottom, what I'm looking at is 64. The 8i's will cancel, minus 8i plus 8i. And then I times negative I is negative I squared. So I'm looking at 56 plus 7 minus 32. That's minus 25i. That 4i squared becomes negative 4 over 64 minus I squared is negative 1. And so that's going to be over 65. So what I'm looking at is 52 minus 25i over 65. Okay. Turning the page, the next question that I would like to look at is 42. So in question 42, we talk about the basics of these absolute value questions. And remembering that when we set up an absolute value, we have to set it equal to the original problem, but we also have to set it equal to its opposite because absolute value means distance. So 5 minus 2x could equal negative 11 because the distance of some value is just 11 units away. So now I add 5 to both sides. Negative 2x equals 16. So x equals negative 8. Here I subtract 5, so negative 2x equals negative 16. Oops, I should be subtracting 5. I'm sorry about that. Let's delete on this side. This should be subtracting 5. That should be 6 divided by negative 2, and x should equal the negative 3. Over here, I subtract 5. Negative 2x equals negative 16, and x equals 8. Okay, the last question that I would like to look at in this section is number 57, excuse me, two more, 57 and 62. So 57, I'm going to solve this proportion like I would any proportion and cross multiply. So I'm going to say, okay, k plus 6 times k minus 4 is equal to 4 minus k times 2. So that's k squared plus 6k minus 4k minus 24 equals, that's a times 2, 8 minus 2k. Combining like terms here, k squared plus 6k minus 4k. Let's move that over to be plus 2k. So that's 8 minus 4. That's plus 4k minus 24 minus 8. Set that equal to 0 and solve for k. That's minus 32. So I'm looking for two numbers that multiply to negative 32 and sum to 4. That would be k plus 8 and k minus 4 equals 0. So k equals negative 8 and k equals 4. The last problem in this section is an absolute value inequality. So I have to take 2x plus 7 less than or equal to 3 and 2x plus 7 with an inequality. I not only set the equation equal to its negative, but I change the direction of the inequality and then solve. So 2x is less than or equal to negative 4. I'm dividing by a positive, so I do not have to change the sign of the inequality. So I want x is less than or equal to negative 2. Here, I'm going to subtract 7, so I've got 2x greater than or equal to negative 10. Again, dividing by a positive number, so the direction of the inequality does not change. And so I want x is greater than or equal to negative 5 and less than or equal to negative 2. And my solution set is right here between negative 5 and negative 2. All right, that concludes the Unit 1 test study guide guided notes.